Hello everyone, it's Peter. Welcome you back. We will continue with the Java OOP concepts. We already covered some OOP concepts in the last class. So in this class, we start with string. String is the most popular class in Java. So you will use string everywhere. But here I need to mention about that string. This class is an immutable class. And also, all wrapper classes are immutable. Okay. So this is very important. The wrapper class means that byte, short, character, then integer, long, double, float, and boolean. So in the basic Java programming, I mentioned that for each primitive type, there's a corresponding wrapper class, which is object level. So string is an immutable class, and all the wrapper classes are also immutable. So based on this, so we need to make an example to talk about Java is passed by reference or passed by value. Okay. Now, to understand this one, I go to this one. Let me give another method, static void change. Change. First, I change as a string. Okay, string str. I change string to new string df. Okay. Now, first I have string str equals to new string abc. Now I go to the change str. Will it be changed? Str. So our result is str is changed locally, but not locally in the function, in the method, but not out of the method. So we can print out here, print out inside change. I have this str, and this is from color plus str. Okay, let's run it. You can see inside this change, str is changed to def, but outside of change is go back to the ABC. The reason is that string is immutable. String is immutable. It's working like any primitive types. It's like any primitive types. So from this one, I can change to okay. Before I go to another example, I want to explain. Because string is immutable, this one I assign a new string to this str. But from outside, str is not changed yet. It is like this is a local copy of str. I can change a name like s. I can change to s. So when in this method, the s point to this df, but outside of the method, the str point to abc. So if I go to this s, that's the concept. So for each method, when we say Java is passed by, we use this word, reference or value. Like this question is passed by reference or value. Use passed by means that the variable will have a local copy. When a variable is passed to a method, it will have a local copy. So it doesn't affect the global copy. But a local copy of what? A local copy of a reference, then we say Java is passed by reference. A local copy of the value, it means the Java is passed by value. So here is a local copy of reference for object or value for primitive type. So this is an arguable question. So from my understanding, the correct answer is Java is passed by value with primitive types. Java is passed by reference for object, like string. Okay, so here I chose use string. String is immutable. So actually, you can. I'm trying to change the value inside of the string, but it's not because it's immutable. The value cannot be changed. That's why it's assigned to another string to this local copy. So it won't infect the outer copy, outside value of the string. Okay. But if I give a class, let's say class A, I have int value. Okay, so I can give a value say equal to 10. Now I write the same thing, but I change this to 8. Now I change the value equals to 20. Okay, I don't need this one. So this method is an overloaded method. So from this example, you can also understand why we use overload. You may say, okay, why I don't use another method name? But it's not. It's very confusing. So we prefer to use the same method name to do the same operator, but for different types. This is an example, so it's easy to understand. So you can pass in a string or you can pass in a class of A. Okay. Now I do another one. A equals to new A. So here in value from column A dot value. Okay. Then I change this A. So then I write after change. Now, see, again, let's see the difference between string and A. In this A, the value is changed. In the string, the value is not changed. See, the color starting from 10, and after change, the value is 20. And for string, start from the inside is changed to DEF, but the outside is still ABC. So why is that? Because let's compare string and A. A is passed by a reference. It's also passed by a reference because both of them are objects. Right? So it means that small a and the small s, they all make a local copy of the object, of the reference. It means that the A has the point to this address. So if I use this way, okay, now I give another explanation to help you understand it. So S at the beginning, the reference point to A, B, C, right? And the str, the outside value str also point to A, B, C. That's true. So S is a local copy of str. Okay. Now, after you use this one, after you run this line, then S is pointing to, this DF. Because string is immutable, I cannot change the value inside this address. So this is the copy of address. So S point to DF is the reference is changed, but str is still pointing to ABC. Okay, so they are totally different now. S and S are different now. Okay. Now go to this change of A. Okay. Maybe I use another name. So the name doesn't matter. So I can use B. Okay. So then when we do change A, so B, so first A point to the value equals to 10. Okay, and B is local copy of A. Now after I do B dot value equals to 20, then for the same address A and B, it points to value which is changed to 20. Right? So B dot value is A dot value because the value can be changed. So that's why we pass both objects. This string is not changed, but the A is changed. The value is changed. Okay. So this is so the final conclusion is Java is passed by reference for objects, passed by value for primitives types. Okay, so I can also add a primitive type. Let's say static void change intx. Okay, so I increase x by 1. Okay, x plus equal to 1. So I can add another one, intx equals to 10. System x is equal to x. Okay, then I change x. After change plus x. Right? So x will not be changed. So inside the local copy, x is changed to 11, but out of the change, it cannot be changed because it's passed by value. Passed by value. So then I go execute. Switch line after change. Yeah, there's a typo. So x is 10. After change is still 10. I just want to use the 3 examples to prove that Java is passed by reference for object and passed by value for primitive types like int. Okay. For both the two change method, and the one is mutable, so the value is changed. One is immutable, the value cannot be changed. So this is talking about again about immutable and the pass by. Okay. Now let's come back. And the StringBuffer is different. StringBuffer is mutable. StringBuffer and the StringBuilder. Okay. Now StringBuffer and StringBuilders are mutable. They can be changed. So, but the StringBuffer is thread safe. StringBuilder is not. So it means that at one time only one thread can access StringBuffer, but multiple threads can access StringBuilder. For the thread safe issue, we will talk about later in our multi-threading class. Now let's run this code again, so I can have another overloaded method if I change as a StringBuffer. Or you can use StringBuilder as it because it's only one thread, so there's no difference. As sb.append, I can append like def. Now let me use StringBuffer equal to new StringBuffer abc. Okay, now let me change. Now this time the StringBuffer will be after change plus sb.toString. I can call toString. So it won't be ABC anymore. It will be ABC DEF. Okay, let's execute. See, ABC DEF. So for StringBuffer is changed because StringBuffer is mutable. Now we clarify the StringBuffer and the StringBuilder. Okay, those things. Now, next big topic is clone and cloneable with the prototype pattern. This is another important pattern prototype, clone and cloneable. From the name, we know clone means that I make a copy of the object. If you just assignment like object A and object B, you just assign A to B, then this is called assignment. It's not the copy. Okay, what we say is we really create a new object, and I copy all the content from A to B. So it's clone and cloneable. Now, how to do that? Again, we go to Java API. Java object. Go to this object API. So we have like here clone. Yeah, here clone. So from those methods, you can see there are two protected methods. Yeah. Protected object clone, and another one is for let's say protected is finalized here. And the last time I already used the finalize method. I didn't change the accessibility. When I override the finalize method, I still use protected. And this is a clone. This one, if you click this one, it also throws a clone not supported exception. Right? So this is a not a runtime exception. This is it need to be caught. Now, let's see how to use clone. Now I go back to this code. Let me write new class. Let's write employee. Employee. So before that, we need to talk about the accessibility. So we have 4 types of accessibility: is public keyword, protected keyword, private. This package accessible means that there's no keyword, there's no modifier. It's called package accessible. So public is very easy. Public can be accessed everywhere. Anybody can access it. It's public. And private is very strict. It's the most strict one. It means that only inside this class can be accessed. For example, like in my immutable person, this is private fields. It means only inside this class, this ID and name can be accessed. So we can get ID, get name, right? These things. And protected and package accessible is more confusing. Protected, let's see. Protected is package accessible plus subclass accessible, and the package is only package accessible. So protected means that if we are in the same package, I can access from one class to another class in the same package. Or if you are in a different package, only the subclass can access it. So it means clone method can be accessed from any subclass. So if I define a class employee, because employee extends the object, the top level class is object, so it can call the clone method. I call clone method. So first I give a two field like ID. I still use ID. String name private. I can use a date. Not use date. Just make things simple. I use double. Sorry. Okay. Now I can use get and status. This is mutable. Now at this time, I cannot call clone method directly. For example, if I make a test, new class, let's say employee test. Void test clone method. To make things simple, I add a constructor. I create a new empty constructor. I create a constructor with ID and sorry. If the ID equal to ID, name equal to name, if the sorry equal to sorry. Oh, here I mentioned about this. This is for the same class. It's not my parent class. So I want to identify this ID and this ID. So this ID here is the input parameter, and this ID means this ID. This is my field. So I assign the ID of the parameter of the method constructor into this ID. Right. So this is a very popular writing to initialize the fields. We also use this way when we initialize the immutable person. Right? At that time, I didn't mention about this keyword. This is this keyword. And for parent, you can use super keyword. I will talk about later. And now, so I first create an employee equals to new employee one. Say here I use new keyword, new string. Alice. Then the salary is, let's say, 50,000. Now I want to create another employee, emp2 equals emp.clone. But now you can see there's a compile error. It cannot be cloned. The reason is that, as I mentioned about, the clone method is protected. Only inside the employee itself can call the clone method. But outside of the employee, we are not in the same package. The object is in the java.long package, so we cannot access it. So then this one cannot be visible from outside of the employee. Okay. How do we do that? So one way is that we can change it to, we can override the clone method. Public object clone. Okay. Then I can call return super.clone. Okay. Now, when we call super.clone, because if you see this one, this clone method, it throws an exception. Okay, throws an exception. So how to handle that? We need to handle the exception, otherwise there's a compile error. This is a checked exception. So what is checked exception or unchecked exception? We will talk about in our exception handling session. Okay, to handle it, there are two ways. One is I throw clone not supported exception. Then it will solve the problem. Now, but here, if I write this one, I also need to throw clone not supported exception. Okay. Use throws. And then I have clone. But this clone will return object. Okay. See, this is object. It's not employee, because clone is the top level. It doesn't know which object will be returned. I can change, when I override it, I can change it to employee. So here I do the downcasting. So here I mentioned a little bit about the upcasting and downcasting for object level. Object level has an inheritance hierarchy. The lower one can be upcasting to the upper one. The upper one, I use the parentheses to downcasting the lower one. Like if I let me write this. This is a very simple one, so I just quickly go through the upcasting and downcasting for this one. So we have class A, we have class B, extends A. This is inheritance. So what happens is I can say A equals to new B, because the right side is a B. This is upcasting. And we can also say B equal to downcasting. This is downcasting. Yeah, this is downcasting. So I can run it. There's no result, but there's no compile error. Okay, I can print out and. Okay. So I quickly go through the upcasting and downcasting. Yeah, easy to say. It's very straightforward. If I assign an object to another object, actually assign the reference. So we know we always talk about the reference at the object level. So if I assign an object reference to another reference, it depends on the class hierarchy. If it's the lower one, it's a subclass, I can assign to the upper, to the parent class immediately, directly, like upcasting. But if I want to assign a parent reference to the child reference, I will add this B. So that's what happens here. I use employee. I can do the downcasting. Now I can make the test. This clone emp dot. Well, I need to save this one, and then you can see this is working now. Now I can run as unit test. So here is a clone supported exception. Okay. Now, here I mentioned about how to test exception for JUnit 5. So I can use this way. Assertions dot assert throws. Assert throws. Then the first one is clone not supported exception dot class. And here this is lambda expression. I use emp dot clone. So then I don't write this line. Then this will work. So it means this means if I run this is lambda expression. I will explain in the future about lambda expression. Is that if I run emp.clone, I expect it to throw clone not supported exception. This is for JUnit 5. This is one big feature that I think is much better than JUnit 4. In JUnit 4, what we expect is this lab has JUnit 4. So if I prepare any, let's find anyone. Okay, let's do a test, new class, test exception. Okay, so let's new other unit test case, test exception. Okay. So if I expect some test has exception, because for example, if I throw new runtime exception, I can throw this exception. So in JUnit 4, I here expected equals to runtime exception class. That's the way. So here I don't need this one. Then I can run SJUnit test. Okay, I will keep this code here. Maybe I move to somewhere. Okay, I just make an example. So it means that for one test case, it can only expect one exception. If this test case can have multiple exceptions, I need to write multiple test cases. But in JUnit 5, so I can, in one test case, I can assert throws many different exceptions. Okay, this is a good point for JUnit 5. Okay. Now, I just keep here. Let's come back. So it means that if I use this way to clone, that's not enough. We have the exception called clone supported exception. So how to do that? We need to implement Cloneable. Okay. This Cloneable is a mock interface, which means this interface has nothing inside. This is interface. So with this way, then we can clone the employee. So I can comment this line. I just keep the code here. Then I can write employee emp2 equals to new emp.clone. Okay. Now we can compare them. Assertions.assert equals 1 emp let's say emp.getID and the emp2 get ID. Okay. Then I can test other things. Is get name, get name. This is get salary, get salary. Okay. There's another good thing is that for get salary there are two doubles. If you use the JUnit4, and you need to add a tolerance because double like 1.0001 for to compare double. Okay, like for double type 10.0001 and 0.99999. Because for some reason we make the one answer like this and another answer like this. They should be equal. But if you compare them directly, then they are not equal, right? It will get a false for that. So in the in unit 4, what we do is I give you example of unit 4 test case in this lab. Let me see, like in interpreter plus test. Okay, so in the double, I have the third parameter called tolerance. Tolerance is 0.0001. It means that if the two doubles, the gap of the two doubles is less than this number, it considered it as equal. So this is unit 4, but the unit 5, we don't have this trouble anymore. We can compare two doubles directly. So unit 5 itself will use the tolerance inside. Now let's run this. Okay, it really makes a different copy. Now again, I want to know if EMP and EM2 they are the same reference or different reference. They should be different reference, right? So asserting, there's another assert called assert same. Assert same and assert equal. The difference is assert same is will be compare the two references, and the assert equals will compare their values. So assert same, EMP and EMP2 are different. Sorry, are the same. Sorry, it's not the same. They are different. They're not the same. I should use this one. They are not the same. Right. And also, I want to compare their name because their name is a string. Right. The string, they are equals. The content is the same as Alice. But how about their reference? I will say the reference are the same. Same. So that's very interesting because the two employees, they have the same ID, same salary, they are primitive types, their values are the same. There's no like this is normal. Okay, we can there's no surprising. But why the string as a name? They are exactly the same. It's not to make a copy of different string. This is called a shallow copy. So shallow copy of objects inside. So if I want to make a clone use cloneable and override clone method, then it actually make a shallow copy of the field. Shallow copy of the field, if the field is primitive, then the value is the same. If the shallow copy of the object, then their reference is the same. So it's like this name. And actually, we can make a deep copy in the future if we learned about serializable in I/O. So we can really make a deep copy. We will talk about it later. But here is a shallow copy. So let me go back to employee. So I can give a note here. Yeah. To make a prototype. So actually, this is prototype pattern. Prototype pattern. Make a shallow copy of an object. To make a shallow copy of the object, it means the class needs to implement cloneable interface and override clone method. Okay, this is the way to do the prototype. And without cloneable interface, it will throw clone not supported exception. We just test it. Okay. I just leave a note for clone and cloneable here, and clone and cloneable. Okay. Now, after this, hopefully this example can help you understand clone, clonable, and the prototype pattern. Prototype pattern is a GOF pattern. Next, I want to talk about the StringPool. I do the test directly. New class StringPool test. Okay. I just use the test. Let's talk about this. Let's say string s1 equals to abc. String s2 equals to also abc. And the string s3 equals to new string abc. Mm-hmm. Now I want to compare their reference and values. Their values are the same, right? So we use equal sign. So again, let's go to the object class top level. There's a equals method. Equals method is to compare their value. So it's easy to do the assertion. So assertions dot assert true. So to make it easy, I can say static. Here I dot star. So I just assert true for what? Okay. We can say s1 dot equals to s2. They are the same, right? And s2 equals to s3. So they are true. So for the content or the value, they are all ABCs. There's no problem. Now, next, I say S1 equal to S2. The reference of S1 and S2 are the same. This is a constant string. This is you use new keyword. Last time we talked about new keyword. If you use new keyword, this object will be created on the heap. It's in the young generation, in the young generation. So, but for constant string, assert false, S1 equal to S3. Okay. And the S1 and S3, they are different. Constant string are created in StringPool. So it means there's only one constant string, like this ABC and this ABC are the same. They have the same reference and in the StringPool. And where's StringPool? StringPool is in the permanent area, permanent generation of the memory. Let's see this one. Again, let's have a review of this one. There's a young generation, old generation, and the permanent generation. And StringPool is created on the permanent generation. It cannot be garbage collected. It cannot be garbage collected. So even you say S1 equal to null, ABC is still there. If you create a code of ABC, this is a constant string. It cannot be garbage collected. And this is a young generation. When we say new string ABC, this is in the young generation. So there are different areas. Of course, their references are different. So the address are different. So that's about this one. Let's run it. This is test. String pooling is also a very typical topic interviewed in industry. But the basic concept is you need to identify the constant string and with new keyword. New keyword it will on the heap, and the constant string is will in the string pool. And the string pool, the same constant string have the same address. It's like this line and this line. So see the difference. So this is StringPool test. Okay. I think I covered most of things, and there's some reflection and introspection. I think I still need another session to cover other topics. And also I mentioned about this and super. Okay, here in my employee class. So when we say clone, it's a super clone. Super is from my parent because myself doesn't have this clone method. I call from my parent super clone. So it means that if I have the same method of myself or from my parent, I can use super or this to identify me or my parent. Also, the same for the field. If I have a intx for me and I have intx in my parent, so this.x is myself's x and super.x is my parent's x. That's this and super. And in our future training, we will use this and super everywhere for many times. So you will understand that. And another big topic like generics, abstract class interface, reflection and introspection. I think I need to leave for the next session. Thank you very much.